All right, so we are going to be doing lesson 19.3, where we are going to be looking at 3 more properties of exponents. So our learning targets are, and let me get my pen, we are going to be able to develop the power of a power, power of a product, and the power of a quotient properties. So then we're going to be able to use those properties to simplify expressions involving exponents. So we're going to explore each of these properties just like we did in lessons 19.1 and 19.2. So it says, write each expression in expanded form, then write the expression using a single exponent with the given base. The first one has been done for you. So we have 2 to the second power being raised to the fourth power. Well, 2 to the second power being raised to the fourth power is telling me I'm going to multiply 2 to the second power by itself 4 times. So we have 2 to the second times 2 to the second times 2 to the second times 2 to the second. Well, each of those 2 to the seconds can be written out as 2 times 2. So this becomes 2 times 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 2. So really we're multiplying 2 by itself 8 times. So we're trying to see, well, what's the relationship then between the exponents that I had when I was raising it to a power and the exponent that I ended up with. So let's see if we can see this pattern in the next one. So we have 5 to the 5th power being raised to the 3rd power. So this is 5 to the 5th power times 5 to the 5th power 3 times. Well, each of those 5 to the 5th powers can be written out as 5 times 5 times 5 times 5 times 5. And I'm tripling all of those. So I would have 1, 2, 3, 4, 5, and then 3 of those. So that would be 15. So this would be 5 to the 15th power. And some of you are probably recognizing, well, what's happening between these numbers to get our final number? And let's see if this holds true for my variables too. So I have x to the 3rd power being raised to the 4th power. So x to the 3rd power would be x being raised to the 4th power would be x to the 3rd power times x to the 3rd power times x to the 3rd power times x to the 3rd power 4 times. Well, each of those x to the 3rd powers can be written as x times x times x. And we'd have 4 of these. So 3 of those times 4 would be 12 times I'm multiplying x by itself. So this would be x to the 12th power. And now you're probably seeing that relationship of, yep, if I'm raising a power to a power, all I need to do is multiply the two exponents. So it says, based on the pattern we observed in item 1, write the missing exponent in the box to complete the power of a power property. So a to the m being raised to the nth would be a to the m times nth power. I'm going to skip down because I just want to focus on exploring what each of these properties mean, and I don't want the video to be too long. So we're going to go down to the 4th problem. So it says, write each expression in expanded form in group-like terms, and write the expression as the product of powers. The first one has been done for you. So if I have 2 times x being raised to the 4th power, well, 2 times x being multiplied by itself 4 times, that becomes 2 times x times 2 times x times 2 times x times 2 times x. And then remember that those coefficients don't belong to the variables. It's just saying multiplication. So we can rearrange our multiplication to be, I'm multiplying 2 4 times, and then I'm multiplying x 4 times. So 2 times itself 4 times, that would be 2 to the 4th power. And x times itself 4 times would be x to the 4th power. So this becomes 2 to the 4th power times x to the 4th power. So we want to kind of see, well, what's happening in here when I'm raising the entire thing to the 4th power? And what's happening with my final? So then we can do the same thing over with the next one. We have negative 4 times a being raised to the 3rd power. So this is negative 4a times negative 4a times negative 4 times a. And again, those coefficients don't belong to the exponents. It just means multiplication. So this becomes negative 4 times negative 4 times negative 4 times a times a times a, grouping my like bases. So I'm multiplying negative 4 by itself 4 or 3 times, so it'd be negative 4 to the 3rd power. And then I'm multiplying a by itself 3 times, so a to the 3rd power. So really, we are attaching those exponents to each of those different bases. Now, this one becomes a little bit different because those bases have exponents that we can see. The other ones did. It was just one. So we have x to the third times y to the second being raised to the fourth. So this is x to the third times y to the second times x to the third times y to the second times x to the third times y to the second times x to the third times y to the second. And so rearranging my like bases, so you have x to the third times 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 y squared times y squared times y squared times y squared. Well, we know that each of these x to the thirds can be written out as x times x times x. So that would be x to the 12th power. And then each of those y squareds would be written out as y times y, so that would be y to the 8th power. So really we're raising each of these terms to another power, which we just saw. We would then multiply our exponents. So x to the third raised to the fourth, that would be x to the 12th, because 3 times 4. And then y squared being raised to the fourth, that would be 2 times 4, so y to the 8th power. So based on the pattern we observed in item 4, write the missing exponent in the boxes below to complete the power of a power properties. So if we're raising power of a product property, so if we have a product and we're raising it to a power, the exponent actually multiplies with each of those bases, exponents. And remember, if it doesn't have an exponent, it's a 1. So 1 times the exponent it's being raised to, which would be that exponent. And then I'm going to go down to number 7, where it says, use the patterns we have seen, predict and write the missing exponent in the boxes below to complete the power of a quotient property. Well, if we have a power to a product and each of those bases is getting attached with that exponent, it's actually the case that this also occurs. And we can see that. I'm just going to do an example off to the side. If we have x divided by 2 being raised to the second power, this would be x squared times x squared, and multiplying straight across, where you have x times x, which would be x squared, 2 times 2, which would be 2 squared. So that each of those get the exponent that it's being raised to. I'm going to do the examples in another video, so if you're still having trouble understanding each of these properties, come back for part 2.